Section is about notebook. The quickest way to learn KumoRFM is to explore our Quick Start notebooks. How to find the Quick Start notebooks? So you can either click the Quick Start, where you can open the Quick Start notebooks here, open in Colab. Another way to find our full collection of notebook is to click the notebook section, where we have a list of a full collection of our notebooks here. So first, let's explore our Quick Start notebooks. This is the quickest way to learn how to use KumoRFM. And from the Quick Start notebook, we first introduce the intuitions of using KumoRFM. And we have a few assumptions here. And the first is your enterprise data is a graph. So as you can see here, we have user table, orders table, items table, and views table. They are connected by keys. So when you are using KumoRFM, it's important to identify what the keys are for each of the table and how they're connected together. So I will show you in the next steps. And then it's very important to have timelines in your events. So by placing events on timeline, we unlock the ability to model to how things evolve over time. So when it comes to data, there's a place where you place a timestamp on your event, so we know what happens at what time. And lastly, we created predict query language and to express all of the machine learning tasks, regression, classification, recommendation, very precisely and concisely using predictive query language. For instance, in the example here, if we want to predict the sales in the next 30 days, there's only 2 lines of code needed from me to make the prediction here. And if you already know SQL, picking up this predictive query language is super easy and it will feel familiar right away. So I will tell you more details in this notebook. And to walk you through the Quick Start notebook, there are a few steps. And the first is we install the Kumo Python SDK. And then we import KumoRFM. The next step is to generate an API key. So if you do not already have an API key in your environment, you can generate an API key here by clicking Generate API Key, and then it will automatically create an API key for you and configure in your Colab notebook. And in the next step, we initiate a client. So what happens is that it will read your API key from your environment and initiate it. So once you can see successfully initiated the Kumo SDK, then you are good to go. The next step is to import your data. So here we put our data in an S3 bucket, but you can put your data anywhere as long as it can be read through a pandas data frame. And another easy way to import your data is to drop your data here, and then you can read your data as a local file from the Colab. And then let's take a look at the data. Okay, I forgot to import. And then let's take a look at the data. So we have the user information, including whether they're active or not and their age. And then we can take a look at the type of the data. And then you can also change the type of the data here. Okay, so next step is to create KumoRFM tables. So the KumoRFM tables acts as a lightweight abstraction of the pandas data frame. And you can see there's a lot of information here, but they will become very apparent once you go through it. So the idea here is to import those as KumoRFM tables And then here, if you read through, the primary key here for the table user are user ID. And the primary key for orders here is order ID. And importantly, we have a time column date in the table of orders. So this is to record when does an order happens. And lastly, we have the primary key item ID in the items here. And so we also provide some very detailed information if you want to dig into the details, like how to set up the tables, how to change the metadata. So it becomes very apparent once you dig into it. And we also provide a quick reference here. I will skip over it. And once you have the tables, the next step is to create a graph based on the tables. So one question we often get is like, how do we get started? What kind of table should you include? And a good guiding principle is to start simple. You can begin with just a barely minimal to get started to support your prediction task. So for instance here, if I just want to predict, okay, what this user is gonna order in the next 30 days, I will just need a user table and order table to make it happen. But here for completeness, let's just have all three tables here. So there are two quick steps. The first is to select the tables here. You can put the tables here, and then you link the tables, see what through the primary key here. So for instance here, so you are making the link between orders table and users table and using the key user ID here. And then once you have linked the tables, you can visualize your graph. So here you can see there's a user table connected to orders table through user ID, and there's an item table connected to order table through an item ID. So once you have your graph, then you're good to go. And you can print the metadata and print the links if you want to inspect your graph. And then we can start to write predictive query to make the predictions. First, let's materialize the graph. So predictive query, as I explained, is how you talk to your model. And we have very detailed documentation about predictive query in the link. And you can follow the link to use our tutorial notebook and read our documentation here for more details. So next, I will show you 4 examples to how to make the predictions based on the predictive query. So the first example is to forecast 30-day product demand. So here, this is the query we have. And so let me explain. So we can start from here. So here what we want to predict is that for items 42, we want to predict in the next 30 days here the total sum of the price for this item. So that's essentially the demand for this item. And here, so this is the prediction here. And so for instance, once you get the prediction, it's very easy to leverage the result for sales forecasting. For instance, if you want to create a chart or graph, it's very easy to pull the prediction and then make the graph here. And secondly, for instance, you want to say, hey, maybe I want to predict on the particular point in time. So here you can use the anchor time here. So what happens is by default, predictions are based on the maximum timestamp in your temporal graph. However, you can explicitly set a historical anchor time to simulate what a prediction would have looked like at that point in time. So this can be super helpful when you are trying to evaluate the results of a prediction. So for instance, if my test dataset start at this timestamp, then I can specifically speculate, say, hey, this is the anchor time, and make the prediction for me. And then similarly, you get the result. So this first case illustrates how you can very easily to forecast product demand. And the beautiful thing about KumoRFM is you can make multiple predictions using the same graph. And what you need to do is just to change the query and to make the prediction. So for instance, let's predict the customer churn. This is also a very popular use case. Say, I want to predict the likelihood that the user 42 and the user 123 will place 0 orders in the next 90 days. So here, let me walk you through the query. Here, so this here, we are indicating the user ID here. So user ID in 42 and 123, we want to predict in the next 90 days. So you can see here, the total amount of count of their orders equals 0. So that's essentially predicting how likely they're going to churn in the next 90 days. Once you have the query, it's good to go. So as you can see here, it's super easy to make the predictions. As long as you can formulate your prediction question into a query, it's very easy to generate a result without all the hassle of training a model, building the pipeline. So let me show you another example here. And say, you already know like this customer going to churn. Maybe you want to recommend some product to those customers. So it's also very easy to do recommendation task. Say, for instance, you want to predict how likely the user 123 is going to buy in the next 30 days. What are top items you are going to recommend to this user? So this is a recommendation case. So here the query looks something like this. So it's super easy to actually to understand. So for this user 123, we want to predict the top 10 items here in the next 30 days. So here we are using a syntax here for recommendation case, which is list distinct. What it does is to list distinct items for this user. So as you can see, traditionally, recommendation problem takes a long time to train the model, to generate data. But here, everything is simplified into this one-line query. Here, you got top 10 items, and then you can serve it in your follow-up. For instance, you can say, hey, this customer, these are some of the items we recommended for you. So it's super easy to generate those high-quality predictions. So the last way to use KumoRFM as an example here is that in the previous 3 examples, you can like predict into the future, but you can also use KumoRFM to infer entity attributes like here. So for instance, for user ID 8, we don't know the original age here, and use KumoRFM, you can very easy to predict the age for this user. So here, for this user ID equals 8, predict this user's age. Okay, here you can get the prediction in about 1 second. Okay, I think that's pretty much it for the Quick Start notebook. And we also have some additional notebooks for you to easily learn and explore KumoRFM. You can click them here. And also, if you have some cool ideas or build something cool with KumoRFM, we'd love to hear from you. You can tag us on LinkedIn, and we are excited to learn what you will build with KumoRFM.